You often hear that people say if you smoke you will get a cancer, but how do they reach this conclusion? How do you know the results are not due to chances? For example, if you roll a coin 7 times and get tails 7 times, can you conclude that the chances of getting tails is 100%? Of course not. We will know that it's 50%. So how do we know that the results of experiments are statistically significant? Welcome to High School Mastery Quarter 1 then. Here we learn how to answer those questions. In Quarter 1, first we learn that how to design an experiment well. We will discuss the characteristics of a well-designed experiment. Then we will learn how to statistically test our hypothesis. In other words, we will learn how to infer that a factor, like smoking, is a significant factor causing cancer. In this quarter, we will use technology such as spreadsheet, statistical applications, and other IT tools to help us do a real-life project. In this quarter, our activities cover the following areas: ongoing learning strategies and attitudes, English language and communication activities, effective uses of technology in the classroom, citizenship and responsibility lessons, physical and emotional issues to address. The common core standards in this quarter are ASSE, interpret the structure of expressions, ASSE 1A, interpret parts of one expression such as term, factors, and coefficients. ASSE 1B, interpret complicated expressions by viewing one or more of their parts as a single entity. ACED, create equations that describe numbers or relationships. ACED 4, rearrange formulas to highlight a quantity of interest using the same reasoning as in solving equations. SID, interpreting categorical and quantitative data. SID 4, use the mean and standard deviation of a data set to fit it to a normal distribution and to estimate population percentages. Recognize that there are data sets for which such a procedure is not appropriate. Use calculators, spreadsheets, and tables to estimate areas under the normal curve. SIC, making inferences and justifying conclusions. SIC, make inferences and justify conclusions from sample surveys, experiments, and observational studies. SIC 1, understand statistics as a process for making inferences about population parameters based on a random sample from that population. SIC 2, decide if a specified model is consistent with results from a given data generating process. For example, using simulation, and a model says a spinning coin force head up with probability 0.5. Will the result of 5 tails in a row cause you to question this model? SIC 3, recognize the purposes of and differences among sample surveys, experiments, and observational studies. Explain how randomization relates to each. SIC 4, use data from a sample survey to estimate a population mean or proportion. Develop a margin of error through the use of simulation models for random sampling. SIC 5, use data from a randomized experiment to compare two treatments. Use simulations to decide if differences between parameters are significant. SIC 6, evaluate reports based on data. SMD, using probability to make decisions. SMD, calculate expected values and use them to solve problems. SMD 6, use probabilities to make fair decisions. SMD 7, analyze decisions and strategies using probability concepts. There is a big project that titles The Effect of School Schedule on Students' Interest. The goal of this project was to know does the schedule affect students' interest. My null hypothesis were double period is not a significant factor affecting students' preference of a day schedule, and there is no significant difference between popularity of each day. My alternative hypothesis were double period is a significant factor affecting students' preference of a day schedule, and there is a significant difference between popularity of each day. I needed to control some factors. To the survey, I needed to pick the class that has similar age and same subject. Teacher can affect students' interest, but in this project, I excluded it because it takes time to students to know about teachers. My project population was NEVA students and sample was grade 10 students. I was collecting data as doing the survey. There were 3 questions. Based on the survey, I got the result. First, probability of students' preference each day. For 10N, day 2 had the highest and day 1 had the lowest. For 10G, day 3 and 4 had the highest and day 1 had the lowest. Second, the margin of error was not higher than 0.23 both 10G and 10N. Margin of error is the error between real mean and sample mean. Third, I did chi-square for each section, which is star 1 to 5. Chi-square is to know the difference between expect value and my sample value. My significant level was 95%, which is 0.05. Degree of freedom was 4 and the critical value was 9.49. Every chi-square score was higher than the critical value, so it means there is a significant difference between day 1 to 5 schedule and students' interest. Fourth, there were factors that control students' interest. Elective class affects positively and double period affects negatively to students' interest. Last, I did t-test each day. T-test is using when we want to know whether there is a significant difference between two groups or not. Day 2 has a significant difference between 10 and 10G students' interest. Day 1 and 4 are also close to a significant difference. My conclusion was my alternative hypotheses were accepted. Double period was a significant factor that affects students' preference and there were significant differences each day. The solution of this problem is changing the arrangement of the double period. We can put double period like day 1 math class. I could finish this project because I learned standards step by step in class, so I could get a good grade or so. Lastly, it is my math GPA for quarter 1. I passed every standard, even I made some mistakes. The good thing of standard is we can know which standard we need to study more. Thank you.